Hello, I'm Mark Granger, Business Development Manager for Emerson's Machinery Health Management Business Unit. Our first demo is called Spring Mass Demo. And the purpose of the Spring Mass Demo is to show that not all vibration measurements are the same. Each vibration measurement has different properties, which leads to diagnosing different types of problems. So to set up this demo, first go into Route Manager, select the Spring Mass route, and then go to the Alt tab, hit User Setup, and in User Setup, the Select Data Display should be set to Waveform. The Select Live Display should be set to Waveform, and the Auto Advance should be turned off. To begin the demo, hit the Alt button and the Back button, and that goes back into route mode. As you see, the 2140 is set up with a triax. The triax is attached to the bottom of a mass, attached to a spring. This is creating an oscillating mass, and what I want to demonstrate is the difference between types of vibration signals. So I'm going to oscillate the mass. I'm going to select the inner button. The 2140 is automatically collecting different types of vibration readings. You can see the PeakVue, the acceleration, and the velocity. The first reading is velocity, and this is in inches per second. Velocity is referring to speed. It's the speed of the mass. And as you see, this is a purely sinusoidal waveform, which you would expect. The second point is acceleration. Acceleration refers to force on the machine. And the difference on this plot is that you still see it's very sinusoidal, but you're starting to pick up actual impacts that are riding along the sine wave. And what these are caused by is the spring actually rubbing against the mass. So on the first, with velocity, all we saw was a pure sine wave, low frequency information. Now with acceleration, we're starting to be able to see some higher frequency information, but most of the energy is still by just the acceleration in g's. The third property that we want to look at is called impact. Now impact is the amount of force that is being applied on a very periodic basis or non-periodic basis. Our impact detection is called PeakVue. PeakVue measures actual G levels. PeakVue is sampling at over 100,000 vibration readings per second. And with that speed of sampling, it allows us to capture the very quick impacts. Now what's different on this is that you notice that the full resolution of the screen is based just on the impacts. The low frequency information, all the sinusoidal energy, is totally filtered out. Now if we wanted to compare PeakVue to another signal processing technique called demodulation, I can go to the next point, do the test again. It's collecting data, demodulation data. And what you'll notice on the demodulation data is that, yes, it stripped out the sinusoidal energy, but look at the impact. Demodulation does not get the absolute accurate peak level.